Welcome to EDU World Space.
Let's use a computer algebra system to go ahead and rewrite this term here, an. So here in Wolfram Alpha, my computer algebra system, if we scroll down here, we see a partial fraction decomposition that we can work with. So let's go ahead and replace this inside of the sigma notation. So that's 1 over n cubed minus 1 over n plus 1 cubed. This will be much easier to work with, and we'll actually can use the telescoping method because this is a telescoping series, as we'll see. So here we can rewrite this infinite sum as a limit, where now we're looking at a partial sum from 1 to k. So this, in the green, including the sigma, this is our sk, our kth partial sum. So using the computer algebra system, we were able to find a convenient expression for the partial sum. So that's sk, and this is a decent looking expression, and the reason this is convenient is because we can use telescoping method. So now the telescoping method will keep writing that limit until the very end. K goes to infinity. So now we start plugging in values of n. We start at 1. So we have 1 minus 1 over 2 cubed. And then we have 1 over 2 cubed minus 1 over 3 cubed. And so on. And then on the other hand, we'll have 1 over k minus 1 cubed minus 1 over k cubed. And then the very last term, when you plug in n equals k, you have 1 over k cubed minus 1 over k plus 1 cubed. Now, before we take that limit, we should go ahead and cancel as much as we can. We can't cancel the 1, so the 1 should still be there in the final answer. However, 2 over 3, we have a negative here. This will cancel with the positive. The 1 over 3 cubed would have canceled with the next term. And then here, we see that we could cancel all the way until we get to k cubed. So we're able to cancel all those intermediate terms. However, you still have one more term left with k plus 1 cubed in the denominator. And then finally, take that limit as k goes to infinity. This fraction goes to 0. So the entire sum just goes to 1. So before we log off, the second part of the question is to go ahead and check your answer using a computer algebra system. So here in the third window, I've taken the sum from 1 to infinity, and the sum is also 1. So our computer algebra system agrees with our sum because we're both getting 1. So that's our final answer.